Good evening, everyone. Welcome to another session of Physics Unveiled. In this particular session, we are going to take up a problem from our DPP, and the problem is based on relative velocity. The problem is right before you, and it is about an rain and man problem, where man is running in rain and there is a wind is also blowing. So we have been asked that in what direction the man should hold his umbrella so that he may not get wet. So let us see the approach road for this particular problem. Okay. So see, this is the direction of rain is falling. So the velocity of rain with respect to air is given, or wind is given, is 20. The wind is blowing in the east direction. Let's consider this is an east direction or x at the same time. Okay. So velocity of wind with respect to ground is given as 15. And there is a man who is also running towards which direction? In this direction only. The velocity of man with respect to ground is given 5. So since we have been asked that in what direction the man should hold the umbrella so that he may not get wet. So in other words, we have been asked to find the velocity of rain with respect to man. So this we have to find out. So let's consider the first frame, wind and ground. These are my frames. So let's draw it. We are observing particle is rain. There is a wind frame, there is a ground frame. So just draw the position vectors fast. So this is RW, this is RG, and this is WG. Okay, so we may write x of RG is equal to x of RW plus x of WG. Position of rain with respect to ground is equal to position of rain with respect to wind plus position of wind with respect to ground. Differentiating this, we'll get VRG equal to VRW plus VWG. Okay, so let's break the thing into components. So we may write that VRGX is equal to VRWX plus VWGX, and another component is VRGY is equal to VRWY plus VWGY. Okay, so let us put the value. VRWX is 0. VRWY is minus 20, considering the downward direction is minus 20. VR velocity, we are writing the velocity, that's why the negative sign is there, it's not the magnitude. VWGX is 15, and VWGY, velocity of winds to ground in y direction, is 0. Let's put the value in the equations. Put value here. So we may write VRGX is equal to VRWX is 0, VWGX is 15. Similarly, VRGY is equal to VRWY minus 20 plus VWG. Okay, VWGY is 0. Okay, sorry, this value is 0. So if we just writing the velocity as whole, suppose that velocity of rain with respect to ground, we may write as VRGX component plus VRGY component. Okay, so we may write it as 15I minus 20J. Okay, now let us check the another frame. Okay, I think we have cleared this thing. So let us take the another frame. We're just keeping this value here. I think you are finding this problem not that tough. It's all about the concept of frame. So in next direction, we are just let us find out two frames. First is rain is being observed. There is man and there is ground. So on similar ground, we may write this is RG. This is Rm, velocity of rain to man. This is the velocity of man to ground. So we may write as next equation as VRG equal to VRM plus VMG. Okay, so VRM, this is a velocity vector. VRM may be written as VRG plus VMG. Now, if you just see the velocity of rain to ground may be written as 15I minus 20J, and velocity of man to ground is only 5I. We just put this is 20I minus 20J. So this is the velocity of rain to man. Okay, so what is the meaning of 20I and 20J? 20I and 20J. 20J is downward. 20I is this. Okay, forward direction. This is 20I and this is 20J. So this is the angle. In this direction, the rain will appears to fall. Okay, so you may find out the angle, this one. So tan theta will be y by x minus 20 by minus 20 minus 1. So it's a negative direction. So actually, this way we should calculate that. So let's go above. So what we have found? We have found that rain is appears to fall in this direction. So this is the rain y direction and this is the x direction of rain. So this is the angle, and in this angle you have to find out this by this. So this is the negative angle. So actually rain is falling in this direction. So tan theta equal to, tan theta is nothing but what is the velocity of rain to man? We have calculated 20I minus 20J. So the J direction minus 20 by 20. So tan theta is minus 1. So minus 45 degree. Okay. So minus 45 degree is anti-clockwise 45 degree. This is the angle. Okay. So I hope we have cleared. So this kind of problem can be solved, using this kind of, first of all, you should draw the frames, and accordingly frames, you should draw the various components, and finally you can get the results easily. So with this, we are completing the solution for DPP series, and we'll meet you with one more new topic of physics for class 11, that is force and motion now, apart from presenting videos on DPP solutions. So till that, have a great day and take care.